Hello everyone, welcome back to my YouTube channel, My Engineering Hacks. In today's tutorial, we will be covering the topic of series and parallel circuits. This topic today is a part of our video by the name of Introduction to Electrical Circuits, Part 1, that we had started in the last lecture. If you want to know more about the basics of electrical circuit, please follow the link which is given below and look for the basics of the circuits. As of today, let's see what all topics will we be covering. Today we will study that what exactly is a series circuit, what is a parallel circuit, how do we measure current, voltage and resistance in both of these types of circuits, and then we will see a couple of examples related to both of the circuits. If you remember from the last tutorial, we had seen that a circuit like this is known as a closed circuit. Now, closed circuit can be combined and changed into two other types of circuits, which are a series circuit and a parallel circuit. In a series circuit, as you can see, the output devices or the lamps are connected in one path or in a series, while in a parallel circuits, you can see there are various paths. So, in a little detail, if I may say, that a series circuit is a one in which the flow of current is only in one direction. You might have seen in some cases that a lamp blows away, and because of that the other lamps also switch off. Such a connection is known as a series connection. Here I have the circuit diagram of a series connection of the same image that I have displayed here. Two lamps which are connected to a battery source. Now how is it different from a parallel circuit? A parallel circuit is something which has more than one path to flow the current. As you can see, this is the circuit which we have implemented in the form of a schematical diagram as well. The current can pass through this one path, the second path, or the third path. Depending upon the number of outputs, the current will have the same number of paths as well. Each device is placed on a separate node, or we call it a branch. Now the main advantage of a parallel circuit is that if one of the lamps blows away due to any reason, the other lamps or the other output devices will keep on working. Now let us see some examples of series and parallel circuits. Most of these examples can be found out at our household itself. Some examples of series circuits are lamps, Christmas lights or Diwali lights, lights in the freezer or refrigerators, while parallel circuit examples can be lighting fixtures as well as house wiring. You might have noticed some of the times maybe a device stops working, but because of that the other appliances don't stop working because all of them are connected in a parallel connection. Now let us see that what is the most important problem with series circuit. Here in the diagram shown, I have made a connection of a lamp with a battery. Along with it, if you can see, I have made the same circuit but using two lamps. What difference can you see in both these pictures? Of course, the brightness. When I have connected less number of components, they glow brightly. But when the number of components increases and when we start putting a resistance also in the circuit, the brightness of the lamps go on decreasing. For a series circuit, the more devices we use, the less current flows in each of the devices. And less current, of course, means more resistance. And more the resistance, as I said, lesser will be the brightness. And of course, we don't want that. Hence, And now let's see if the parallel circuit also has some advantages, or does it also have disadvantages only? Well, some disadvantages of parallel circuits are a lot of devices, although they can be connected together, but because of that, there are chances that the wiring system or the devices may heat up, which may in the future damage your device. So we have to be very careful about the fact that how many devices are we plugging in together. And another disadvantage of a parallel circuit is that energy is rather used up too quickly. But both of these disadvantages can be converted into advantages as well. If the devices heat up, or if the energy is being used up more quickly, or if there is any fault which we may think that may happen to the device or the house or any appliances, for that error we use circuit breakers. Most of us have seen different types of circuit breakers. They are almost at the entry of each houses. You might have seen a fuse, a circuit breaker, and different types of circuit breaking devices. Can you name a couple of circuit breakers for me? If so, please don't forget to mention the names in the comment section below. Moving ahead, let's go to the next topic, that is, how to measure the current, resistance, and voltage in a series circuit. The voltage source is connected to three resistors in this diagram shown. Each resistor is named as R1, R2, and R3. The voltage source remains the same. That is, the starting voltage remains the same, but there is a voltage drop across each resistor. In more simpler words, the voltage value will be different at each value of resistor. As you can see, there is only one path for the current to flow. Hence, we can say that current in the circuit remains the same. Here are some of the equations with which we can calculate the voltage drop, the total voltage, resistance, and current in a series circuit. Total resistance or equivalent resistance is calculated by adding all the resistance in a circuit. And as I said before, the total current in a series circuit is equal at all the points. Whereas the total voltage can be taken as the sum of voltage drops across each of the resistors. In a series circuit, we say that the more the resistance, more is the voltage drop. So if you come across such a question that which part of the circuit has the highest resistance, just look for the highest voltage drop. Depending on the same, let us see how we can calculate current, resistance, and voltage in a parallel circuit and how these measurements are different with respect to a series circuit. As you can see, all of these resistors or all of these output devices have different branches. Each branch is connected at a point which is known as a node. For a parallel circuit, the voltage across each of these branches remains same, unlike in series circuit where it was the current. Resistance changes and current across each branch changes as well. So how do we calculate these values? The value of resistance or total resistance is obtained by this formula. 1 over RT or R equivalent, whatever you want to write, is the sum of the reverse of all the resistances. And finally, when you get the reverse value, you have to convert it back to R. You have to divide 1 with the value of your obtained resistance. Total current, as I said, sum of all the currents across different branches, whereas voltage, the total voltage across the battery, is the same as that in each of the branch. Now let us see how do we measure the value of current, voltage and resistance in a series and a parallel circuit. Well, not the calculations, but using the measuring devices. Do you remember the name of the measuring devices that I had told you in the previous tutorials? Yes, that's right. For measuring current, it's ammeter. For measuring voltage, it's voltmeter. And for measuring resistance, it's ohm meter. So in a series circuit, when we have to measure the voltage drop across any point, we connect the voltmeter in parallel to that appliance or that device or that point. While if we want to find out the value of current flowing through a device, we connect the component in series with the ammeter. Well, same goes for a resistor as well. If we have to measure the value of resistance, we connect the ohm meter in parallel with the component that we want to find out the value. And as for a parallel circuit, it is the same. The rule does not change. Voltmeter and resistor are connected in parallel, whereas an ammeter is connected in series with the component to find out the measured value. Now let us see some examples of series and parallel circuits. Say I have a circuit here with the input voltage of 120 volts, resistance of 20, 12 and 50 ohms. I have these 5 values which I want you to calculate. Can you calculate the value of total resistance, total current and voltage drops across each resistor? Total voltage drop, and what do you think will be the relation between voltage drop and voltage across the resistors? Well, I hope you got most of the answers right. As discussed before, total resistance is a sum of all the resistances, so that is easy to calculate. Similarly, using Ohm's law, we know current is equal to voltage divided by resistance. For this part, we talked about total current. So it is total voltage over total resistance and not the current at a particular point or at a particular resistor. Therefore, we divide total voltage by total resistance. And as you know, in a series circuit, current across each of the element is same. So current across each resistor is also equal to the total current. Now, if we have to find out the value of voltage drop across resistor 1, resistor 2 or resistor 3, again we use the same old Ohm's law. See how often Ohm's law has been used? So it's very important to remember the Ohm's law triangle for you. So the voltage drop across resistor 1 will be I times R, of course, but I1 times R1, I2 times R2, similarly I3 times R3. This formula gives you the value of voltage drops across the three resistors. And finally, if you add all of these values, you will see that total voltage drop is equal to the voltage across the battery. So the relation between the voltages here is that both of them are equal. Similarly, if we see the same diagram with the same values but connected in a parallel circuit, the same values we have to see, but there will be one change. Instead of voltage, do you remember what is same here? Yes, the current. So how do you calculate the values? Before I give you the answer, why don't you try the question for a while? So here is the solution. We find out the R equivalent, rather 1 over R equivalent using the formula. And when we get the value, we invert the value and find out the total value of resistance. Similarly, we calculate the total value of current using the total value of voltage divided by total value of resistance in amperes, of course. And as we said that voltage across each branch is same and it is equivalent to the total voltage. Hence the total voltage will be 120 and voltage across each branch also will be 120 volts. And again, using the same Ohm's law, we find out the current across each branch. part 3 of the series of Introduction to Electric Circuits is on its way. Till I see you again, please take care of yourself and your family, and don't forget to like, comment and subscribe to my channel as well.